2 weeks in and it actually caught one. Let's have us a wee boo with poor Pifle. I got a live and let live attitude, but you come in my shop, piss and shit in the corner, and complain about the smell. Don't matter if you're 2 ounces or 200 pounds. You fucking can! Gentlemen, welcome back to the shop. This fine autumnal eventide, we're going to have a poke and a prod at something, what for killing mice. Cost you 400 times more than regular old standby, but only work half as good. This thing appears to be surmounted in ABS plastic. That's the kill floor there. One electrode, the other electrode with the bait. And it's keyholed just to pop right off. Not much to that. Couple of little contacts here, spring loaded. Those appear to be just sheet metal with some zinc coating. Probably needs some oxidation resistance since there will be not only blood but pee. We see a through hole on the power pack with a micro switch deployed in order to index on a tab protruding through the trap itself, the trap section. I assume in order to allow it to energize these two, you wouldn't want this just chooching on its own. Let's see. Yeah, it's not firing. And already we see some beautiful engineering. Brilliant, actually. Cost optimized to reduce the bill of materials, both number and cost. Normally you would see just 6 screws side by each, but instead they've gone with tabs. So less assembly, less BOM cost, same effect. This is a very low impact casement, low need for skookumness. So that's a great idea. Oh, and interesting. Rather than being made in China, it's made in Vietnam. This is not called offshoring now, it's called friendshoring, where we're starting to see a lot of manufacture move out of the People's Republic of China and into lower cost, lower labor cost countries. Aha! I am aware that each one of us has a little sadist. However, I have very little masochism in me. So I will be putting these alligator clips on there just to make sure I don't get lit up like a Christmas tree. Remember, it's not the voltage that kills you. It's the voltage and the current. I don't think this would kill anybody but a mouse. The topology of the circuit is a little more refined than I would have expected. I thought just a voltage multiplier across those 2 leads and zappy zap zap zap. Nay, we would need a plethora of diodes in order to have a capacitive voltage multiplier. What we have here is a big inductor, a transformer, bunch of little brain boxery, low voltage capacitors, so these aren't on the high voltage kill side. Looks like a big skookum bleed down resistor or maybe a current limiting resistor on the inside in case something fries. I'm curious to see what voltage this operates at, but it's quite clear that there's some calculations going on here. Since we have an inductor, they must be checking the impedance across these 2 guys. And that would make a lot of sense actually, because you'd be killing your AA batteries very quickly if this was constantly on. And also it would be noisy. So what's happening here, this inductor doesn't work. It's not going to work for high voltage. Well, it's a transformer, so it needs changing current in order to work. So that is what this MOSFET on the back side is for. A single MOSFET, so that means it's just switching that DC very quickly. You'll be able to likely hear it. And that is not a big, cheap capacitor. It is an inductor, as witnessed by the iron core. This would be wound in such a way that the 5 volts from the batteries would get us up to 10,000 volts. Aha! We caught him. We caught him. Shortcuts. They messed up on the design. Look at this injection molded plastic case. It's all chewed up there. It's hitting on this IC. On this IC. I see you. Should have fixed that. So what they did was they took this board out. I was wondering why it looked cattywampus. They took the board out, moved it sideways a little bit, and then jammed it in there. Yeah. How are we going to fix that? I know just the thing. Time for your bris. It's for your own good. Remember, Hashem, or the previous, well, whoever he was, he only likes perfect specimens. You cut the tip off, and your mother Sarah saved you from. Had her back together, pulled out the old oscilloscope, and I mangled the on switch. Oh, trying to get it back together. I think what I did, I just squoze those two. Now it falls out, so I'll unsquoze them. Yeah. Good as new. There you go. A little extra twist at the tip. All right, let's invoke the spirit of the blue smoke monster. I have a voltage divider there, 2 mega ohms and 1.2 kilo ohms. Ought to see about 5 volts across there if it's 10,000 volts between the two. Should I explain how that's done? Yeah, maybe. Just for dead reckoning, figure it's 10 kilovolts. Just a good round number to start with, across those 2 kill plates. What I did was take 2 resistors in series, like that, and yes, they are that ugly. Put in 2 mega ohms. Mega with a capital M. And then I put another resistor in. That's 1.2 kilo ohms. 1200 ohms. So what I'm expecting to see here across my oscilloscope is about 5 volts. That's what I want. So if I just go equals, I just multiply by that one, divide by that one, it'll give me that one. 2 million times 5 divided by 1200 is 10 kilovolts. You'll have to do the math on your own. I can assure you it's close enough for the girls I go out with. It's called a voltage divider, and it's very useful for measuring high voltages. All right, here's the waveform it's putting out. Just pulses at 238 hertz, 9.2 volt spike across that 1.2 kilo ohm resistor. So we'll do a little mathematics and I'll tell you how much voltage is there, approximately. Peak voltage 9.2 volts across that 1.2 kilo ohm resistor. 9.2 volts times 2 million ohms divided by 1200 ohms equals 15,000 volts and change. I think we're a little high. Now this is interesting because it's putting the mouse's heart into an arrhythmia. It's not frying the mouse. It's giving teeny pulses of high voltage in order to set up an arrhythmia and kill the mouse that way. Probably not very fun for the mouse. This thing works quite elegantly and efficiently to kill the mouse. It works efficiently because it's not constantly using up the batteries. It's waiting in a quiescent mode until it senses that there's a paw between the 2 electrode pads, and then it sends a jolt for a period of time in order to kill the mouse with basically having a heart attack. Apparently this works for 4 weeks on a set of batteries. Don't quote me on that. I threw out my Mexican buddy, El Manuel. There you have it. That's how that works. Thanks for watching. Keep your dick in a vice.